Assalamualaikum warahmatullahi wabarakatuh. Okay, so now hari ni kita nak sambung Electromagnetism, Electromagnetic Induction Part 2, where saya nak terangkan dia punya main application. Okay, so kita dah belajar all the theory before dalam Part 1. Dah belajar macam mana nak hasilkan current and so forth. So, dia punya application dia ialah kita boleh buat generator. Meaning kita boleh generate the current tanpa perlu menggunakan power supply. Okay. Okay, so first saya nak tunjuk dulu differences between motor dengan generator. Okay, so motor kita guna current carrying conductor. So kita kena ada source of current, which is power source lah. Tapi untuk generator, notice that kat sini tak ada power supply. Okay, so tu beza dia. Bila buat soalan nanti, tengok dekat circuit tu ada power supply ke tak ada. Kalau ada power supply, maksudnya dia adalah sejenis motor. Kalau tak ada power supply, dia adalah sejenis generator. Sebab awak kena ingat, motor rule dia Fleming left hand rule. Kalau generator, kita kena guna Fleming right hand rule. Inilah nanti. Sebab soalan boleh jadi dia tanya direction of current ke, direction of force ke, apa-apalah dia nak tanya. So that's why awak kena tahu generator ke motor. Even though dia punya DC motor dan DC generator ni, dia punya working principle almost the same, cuma direction lah tak sama. Sebab satu kita guna right hand, satu kita guna left hand. Okay, so now let's start with DC generator dulu. Okay, so DC generator, dia ada satu je commutator kat sini. Satu commutator, dia sama macam DC motor punya setup, cuma beza dia tak ada power supply sahaja kat depan tu. Okay, dia terus ada carbon brush, spring, commutator dengan coil lah. So, sebab saya kata dia sama working principle dia. Okay, first, generator, remember, kita yang gerakkan dia. Okay, kita yang gerakkan dia. Jadi, bila kita yang gerakkan dia, force ni, movement ni kita bagilah. So, kita bagi movement tu counterclockwise. Meaning, macam biasa, kita ada A, B, C, D for the sides. So, AB turun bawah, CD naik atas. Jadi, kita boleh cari current dengan menggunakan Fleming right hand rule. Okay, so buat macam biasa lah, north to south. And then kita ada movement dia upwards. So kat sini kita akan ada current ke depan. So ke sini, ke sini. Jadi current lalu ikut mana? Ikut sini. Okay, that is our current punya direction. So galvanometer akan deflect. Ni galvanometer yang bulat ni. Galvanometer akan deflect ke sana. Ke kiri. Okay, sebab current kita ke depan. Okay, now then, apa akan jadi? Macam biasalah, dia akan parallel to the magnetic field. Jadi, tak ada no cutting of the magnetic flux kat sini. So, kita punya galvanometer akan jadi 0 sebab no current flow. Tak ada berlaku cutting of magnetic flux here. So, tak ada current flow. Jadi, tapi dia still akan jatuh, remember. Because of what? Because of inertia. Sebab tu saya kata konsep dia sama je dengan motor. Okay, dia akan jatuh tapi because of inertia. So notice that sekarang ni bila dia jatuh, AB akan tukar side dengan CD lah. Okay, so tadi ingat dia punya current ke kanan. Kita tengok yang bawah ni . So current dia to the right. Okay, now kita tengok apa jadi bila dia jatuh. So, bila dia jatuh, dia dah tukar side. Bila dia tukar side, kita tengok direction of current now. So, direction of current sama je. Macam tadi. Tak ada beza. Okay, galvanometer masih deflect belah sana. So, direction of current sama. And then, dia dah pusing. Straight line balik. Kat sini, dia akan jadi 0 balik. Okay, sebab apa? Sebab tak ada cutting of magnetic flux. Jadi tak bergerak. So, you notice here that DC punya generator, direction of current, sabar saya nak tulis kat sini. Okay, DC generator tadi kalau perasan, direction of current dia sama. Direction of current only in one way. Kan? So, bila direction dia current dia sama, jadinya kalau dalam electrical punya appliances, contohlah kalau dalam graph, current awak belah atas je. So, maksudnya kita akan produce a very direct current nama dia. Kalau current kita atas bawah, yang ni baru dinamakan AC. Tapi for this one, for this setup, dia adalah sejenis direct current. Okay. Okay, so kita tengok dulu video ni. Video yang menunjukkan illustration of DC generator.
Hi and welcome back to my YouTube channel. Have you ever wondered how DC generator works? And what are the basic parts of a DC generator? This video will give you the answers to these questions. We will start with the basic parts of the elementary DC generator. As you can see, the configuration of DC generator is pretty simple. The split ring is a movable device used for reversing the polarity of the current. It's made of copper. The ring is divided through the middle into two parts. We must use the split ring to achieve single direction of current. The brushes are made of carbon. These are rectangular block-shaped. The only function of these carbon brushes of DC generator is to collect current from commutator segments. A galvanometer is an analog electromechanical actuator that produces a rotary deflection of some type of pointer in response to electric current. So how does the DC generator work? Firstly, we don't want that current direction to change. We want it to remain the same at all times. Let's say in this direction. So, how do we do that? Now, to make sure that the current direction remains the same, what we require is that these brushes constantly keep changing contacts between these wires for each half of rotation. So, if the current flows in this way, in this position, this brush must be connected to this wire. So current flows like this and comes out. But when the coil rotates, you can see that when the coil comes to this position, the direction of the current changes. If we want to keep the current in the same direction, we must this brush to be in contact with this wire. Right. And then again, when the coil comes to this position, again the direction of the current changes, and again we want this brush to come in contact with this wire. Probably we already learned that. For every half rotation we must change contacts between brushes and wires. But how do we make this process happen automatically? We can automate this process by adding split rings. Split rings, as the name suggests, is a ring that is split in between, giving two half rings with the same gap in between. Now let's see how the split rings automatically change contact for every half a rotation. So right now this brush is in contact with this half part of the split ring, violet color. When the coil rotates and comes to this position, the direction of the current changes, and this brush now is in contact with the other half part of the split ring, pink color. This arrangement provides that current flows in the same direction. Again, as the coil comes to this position, finishing another half a rotation, you can see that this is only changed contact. Brush is in contact again with the violet color half part of split ring. In this way, the DC generator is built, where the current only flows in one direction through any external circuit, and in this arrangement, with brushes and split rings, which helps us to automatically change contacts, we call them commutators. So split rings act like commutators. The next thing we must mention, that it's really important for working principle of DC generator, is how can we determine the direction of the current, magnetic field and force. To determine all this, we must use Fleming's right-hand rule. So we will explain how can we use Fleming's right-hand rule. As you can see, the rotation of the coil is clockwise, and the force acting on part of the coil AB pushing that part of the coil upwards. So to know the direction of the induced current, we apply the Fleming's right-hand rule. How do we do that? We place our right hand so that the thumb points up, showing the direction of the force. The index finger or the finger pointing in direction of the magnetic field from north to south pole, and middle finger will point in the direction of the induced current, which is in our case from A to B. Similarly, to find the induced current in a part of the coil CD, we again use Fleming's right-hand rule. So the rotation of the coil is clockwise, and the force acting on part of the coil CD pushing that part of the coil downwards. The thumb points down, indicating the direction of the force, indexed finger or for the finger pointing in direction of the magnetic field from north to south, and the middle finger will point in the direction of the induced current, which is in this case from C to D. So to conclude, the induced current follows the path ABCD of the coil. The effect of the split ring commutator in DC generators is to ensure that the induced EMF is always in one direction. We can see that in this graph, where V represents the amount of induced EMF and T represents time. You will notice in the graph how the sine wave changes with rotational speed of the coil. The coil in this case has clockwise rotation. Increased rotational speed of the coil increases the amount of induced EMF. The induced EMF has a positive sign. Also, you see the example how the sine wave changes with rotational speed of the coil, when the coil is rotating counterclockwise. Again, the increased rotational speed of the coil increases the amount of induced EMF. In this case, the induced EMF has a negative sign.
Okay, so I hope you understand. Okay, ni graf yang tadi tu saya cerita tu. Okay, so induced current kita untuk DC dia dapat sama je, dia dapat satu direction. So direction dia positif je. That's why kita panggil dia direct current. Bila time yang dia tak cut the magnetic flux tu zero lah, current dia tak ada. Okay, ni bila time tak cut the magnetic flux. So dia akan maximum dia punya current bila dia punya kedudukan ialah betul-betul perpendicular to the magnetic flux. Okay, so that's untuk DC. Okay, now we go to AC generator. Okay, this one awak kena perhatikan betul-betul. DC ada satu commutator, tapi AC generator ada dua commutator. Okay, satu belah atas, satu belah bawah. Yang penting dia ada dua lah. Dia ada dua commutator, dua slip rings, dua set of slip rings. Okay, carbon brush masih ada dua, tapi kita tambah commutator kat sini. Okay, now kita nak buat apa? Okay, so now working principle of AC generator. Okay, so saya saja je buat bagi colour dia lain sikit, semoga awak nampak. AB commutator dia ni yang colour orange ni. CD or peach, CD commutator dia yang colour pink. Okay, so AB, side AB ni commutator dia first attach dengan carbon brush P. So commutator CD attach dengan carbon brush Q. Okay, now kita tengok direction of the current dulu. So this one akan naik atas, this one akan naik atas lah ke depan. Dia lalu sini, dia lalu sana, dia lalu sini, dia lalu sini kan. Dia lalu sana balik. Okay, so kita punya galvanometer akan deflect to the right. So current kita ke sana, galvanometer to the right lah. Okay, and then macam biasa dia akan jadi parallel with the magnetic flux. So tak ada current lah flow. Carbon brush pun tak bersentuhan sebenarnya dengan slip ring. Therefore zero induced current. So dia akan jatuh because of inertia macam biasa. Okay, now kita tengok bila jatuh, AB akan jadi side kanan pula, CD akan jadi side kiri. So now let's see current flow ikut mana. Okay, so ni ke depan, ni ke sini, ni ke sini, ni CD ni kat kleping kan. Okay, ke sana, ke sana, ke sana. Jadi sebab current flow ke sana, kita punya galvanometer sekarang akan deflect the other way lah, ke belah kiri. Okay, and then ulang balik benda yang sama bila galvanometer akan jadi zero. Okay, so kalau awak perasan tadi mula-mula galvanometer kita belah sini. And then galvanometer kita straight, and then galvanometer kita belah sini, and then straight. Okay, ni galvanometer kita sekarang ni ada dua direction. Satu ke belah sana, satu ke belah sini. So kalau tengah-tengah ni value dia 0, so this one will be a positive value. this one will be a negative value. So this is why kita kata bila ada dua commutator, kita akan menghasilkan current yang ulang alik. Okay, positif, negatif, positif, negatif. That's what we call as AC generator. Kita punya current positif, negatif, positif, negatif, positif, negatif sampailah kita stop moving the coil lah. Okay, that's what it means by AC generator. Okay, ni illustration dia macam dalam video ni. Okay, so untuk AC generator, kalau kita tengok graph produce, graph of induced current against angle. So, masa dia dekat 90 degree, of course lah the highest value of the current flow. Masa dia dekat perpendicular to the magnetic field. And then 0, bila dia 180 degree, straight line macam tu. And then, kalau dia akan jadi negatif sini, maximum negatif. Yang tadi kan, sebab dia punya direction of the current dah berubah. And then, come back to 0. Okay. Tu je lah untuk AC and DC generator. Awak kena tahu direction of current dulu. And then baru boleh tengok galvanometer. And you will see that galvanometer dia punya ni akan berubah. Okay. Direction dia berubah. Kalau direction tak berubah, tu namanya DC lah. Okay. Okay, similarities. Diorang punya similarities between DC and AC ialah dua-dua applies electromagnetic induction. Sebab dua-dua kita produce the current. Coil is rotated by external force. Yes, kita yang gerakkan dia. That's why kita boleh create current. So, coil cuts magnetic field, same EMF induced. Okay, semua sama. Beza dia ialah direct current. Ingat, dia ada satu je commutator. Split ring commutator. Alternating, dia ada dua. Okay. So, two section of the commutator exchange the contact with the carbon brush. Kita nampak tadi. A dengan B. C dengan D kan. So, diorang akan keep on changing the contact. Mula-mula A, B contact. Lepas tu C, D pula contact. Ada macam tu. So, output dia direct current. Untuk AC, tadi kita ada dua carbon brush juga. Satu P, satu Q kan. So, slip ring ni dia ada dia punya carbon brush sendiri. Dia orang tak payah kongsi. Okay, untuk DC dia kongsi carbon brush yang sama. So, output is alternating current. Tu beza antara AC dan DC. So, that's 4.2. 4.3 transformer. Saya akan ajar, tengoklah next week ke macam mana. Tapi for now, ni je lah dulu. 4.1 and 4.2. Please fahamkan. Awak ada cuti ni dalam beberapa hari. Tak hari lah, seminggu lebih kan. Tolonglah fahamkan. Dan tak faham pun latihan banyak-banyak. Okay. Dan please check your Edmodo. Saya dah upkan assignment. And also akan ada quiz coming for this 4.2. Alright. So that's that for today. Thank you.